the automated scheduling for small colleges and high schools. So first thing we do is open up this spreadsheet. This is a sample. Um, this is a sample numbers file. This is like Excel, but for the Apple system. And notice first we have all the classes, how many periods a week need to be scheduled. Is it a lab? Labs are scheduled contiguously. The capacity, this is the amount of students who are allowed to be in the class, and it's a hard constraint, which means it'll never be violated. So one should make this number as big as possible, especially if you want to go over the normal capacity. The minimum enrollment, not really using it at this point, but you can put any number in here. I put 5, but you could also just put 0 there. If the class needs a final exam, so you would put a name for the final exam. And in this spot would be the room type. Is it a classroom in a certain building, a certain type of physics lab? Next is the lab type field. So what this does is it forces students who are in a lecture with a certain professor to also be in their lab course if they have one. So you just simply put the same number in both the lab and the lecture, and that'll guarantee that students who are enrolled in this lab will also be enrolled in the lecture. If you want to be sure that a certain course is scheduled on a certain day, so in this field right here, day 1, you would put Monday through Friday, and then the corresponding hour that you want it scheduled, which period. Now you do not need to specify a period. If you just want it to be on a Monday, then you can simply say put an M there. And if you want it to also be on a Tuesday, it'll just put a T there, and then the program will choose the best time for those lectures. So you do not have to always tell the program what time you want a class scheduled. It's enough to just give the day. All right, and then there are many days. You can do this for up to 4 days. And next, we have multiple instructors teaching the same class. So this professor is last name D, first name D, and Professor E. So they both have to be available to teach this class. Okay. Is the professor an adjunct? So you could put the code A over here. And this last code double, what this does is it forces 2 classes to be taught at the exact same time. So you don't have to split up your groups of students into tiny groups. So there's 2 statistics sections. One is taught by Professor B, one by Professor C, and we want them to be taught at identical times. So you put the same number in both of them. These things don't have to be numbers. I believe they could be any alphanumeric code. And I think that would also work for the lab ties. These could be any alphanumeric code if you find it more convenient. But I think numbers might be easiest. um, so those are the sections, the classes that are going to be offered. And we have our database of rooms. Um, Notice that each room has a name, and it's a unique name. You can't use the same name for two different rooms, even if they're in two different buildings. They have to have unique names here. And this is the room types and the capacity of each room. Um, Next, we have the groups of students who need various courses. So these are the students here. So the first group of students is called A. You can put any alphanumeric string there. Any name, doesn't matter how long. And how big is the group? How many students are in this major, this split? And then you simply put the name of the course that they need. And notice that these names are all on the upper part of the spreadsheet already as the name of the courses. So these are the course names. And by the way, the section number is just the row number. So section number 7 would be row 7. Section number 8 would be row 8. Right. So going back down to the students, you can put as many classes as you want, but you want to make sure they don't exceed the total number of periods, which I don't think would happen by mistake. Right. Try not to forget the labs that go with the different lectures, and make sure the spelling is the same as it is in the top part of the spreadsheet. Okay, finally, we have the professors. So there are 3 levels of preferences. So A is the strongest, like for an adjunct or somebody who absolutely cannot teach at a certain time. So this is Professor A. He cannot teach on Monday at all, so this would be a very, very, very strong weight that would prevent him from teaching on Monday, and he wouldn't be teaching on Friday. So he would get the highest priority when the schedule is formed. The next highest priority is D for documented. Like somebody has a documented reason, they have to pick up their children from school or care for a dependent adult, or anything that they, a better reason, a good reason, but not an absolute reason. So you could put a D there. That'll be the next strongest. It's 10 times lower in weight. And finally, the lowest priority is just to put a 0 there. The 0 just means the professor prefers not to teach at that time. But he can, and he doesn't have a really good reason not to. He just doesn't want to. So that's fine to put in, but it'll be the lower priority than the other requests. All right, and each professor would have his own little matrix here. All right. And that's the entire spreadsheet. So once you fill this out, we're ready to calculate the schedule. So first is we have to save it as a CSV file. So we're going to first save it, and then I'm going to export it to a comma separated value, This could be automated, but right now it's not. So saving it to sample.csv. All right, so now we don't need this for now. I'll minimize this. Notice our directory that we're in has 3 files. This is the program that actually does the scheduling. It's written in Python. And this is the spreadsheet. It's like an Excel spreadsheet. And this is the comma-separated value format of the spreadsheet. All right, so now we're going to run the program. So I'm in the same directory. So the command would be python ms.py. ms.py is the name of the Python program. And then it's called sample.csv. That's the name of the master spreadsheet that contains all the information. And then double hyphen and solve. So this tells the program to solve the schedule. All right, so the first thing it did, I'll go back over it, but first thing it did was it split up the groups into mini groups because the groups are too big to fit into certain size classes. So it had to break them up into smaller mini groups. All right, it solved the problem and it generated PDF files. So this was just a baby schedule, a small schedule. Now, as you can see, it solved it pretty fast. So let's go back up. So first it does some checks. This is a list of all the sections. It goes from section 7 to section 49. And there's some warnings. So the following sections were never requested, so none of them. They were all requested. But you might end up with sections that were never requested. And then at this point here, this is where the mini groups are formed. You don't really have to pay attention to this part. It does it automatically. And here it starts to actually solve. Here it actually solved the problem. Notice, so this is where it actually solved the integer program. It took 24 seconds to solve this rather easy version. And then it generated 4 PDF files. So here are the PDF files right here. So let's take a look at them. So all right. So here are the PDF files. So the first one is groups. So these are the groups. And notice this is group A1. The slack in the group is how many people you could add into the group without making any class overcapacity. And this group has size 2, so there's only 2 people in this first group. Group A2 has size 17, and it has slack 0, which means you couldn't put anyone else in this group unless you want to overflow some of the classes. And these are all the courses they're enrolled in, the room, and it tells you how many are enrolled in each class. And if we look at all the groups, there's 12 different groups. See, originally C was one big group, but it got split into 3 groups of size 11. So C3 is 11, 4, and 10. Notice they have different schedules, though some of their classes are the same. All right, so these are the groups. Okay. Next, we have the section schedules. So there's 43 sections that were scheduled. And in the next version, I'm going to also put here the different groups that are enrolled in each section. I think that might be useful. So these are all the sections that are scheduled. Like here's Stats 2 with Professor C, section 15. It has an enrollment of 12 and has a capacity of 17. Right, so those are the sections. Next, we have the professor schedules. So here's all the professors. Notice if they're co-teaching a class, it also shows up on their schedule automatically. Okay. And finally, we have the room schedule. All right. So here's Ackerman. That's the common hour, and then the electives. Here's one room, B102. So here's a Fulton room. And notice this is a rather easy schedule, and it only took 20 seconds to solve. The actual schedule takes 7 to 15 hours to solve. It grows exponentially, but thankfully it can finish it within a day. All right, so that's the idea of the entire program. The entire program is a Python file, and this is the code. This is the code for the program. It's basically, the whole thing is about 1,400 lines, which is not bad for a program. Most of it is setting up the data structures, and only a little bit of it does the actual solving.